So we live in a world of technology. That's not a very surprising thing to hear. After all, you're probably watching a recording of this talk. Technology is pervasive, and it is everywhere. And when we think about technology, and when we think about phones or laptops or computers in general, we're thinking about computers that take a series of instructions and execute it. When I want something to happen using a computer, I have to tell it exactly what to do and how to do it. There is no room for ambiguity when you're telling a computer what to do. There can't. A computer is not good at doing something that you didn't tell it to do. But that's changing. Increasingly, we are training computers how to do something instead of just telling them. Take Face ID on the iPhone X, for example. In the past, if you wanted to detect a face, you had to take an image and have your program scan through every single pixel, every single bit of visual information encoded in that picture in order to determine exactly who is there. It has to sift through that visual information and sort out which bits of information are relevant to the task of finding and identifying a face, and which bits of information are not relevant at all. Light levels from the surrounding area can distort the image, not to mention the fact that it can usually be fooled by a picture of you. By contrast, it is a much simpler process now because of machine learning, a way to teach a computer how to perform a task, instead of just providing instructions. Now, instead of comparing every single picture to an image in some sort of master file, this program can learn and draw its own conclusions. It does this through neural networks, a system of computerized thinking that's based on the human brain itself. In a neural network, we provide a computer with a large set of training data. In this case, that can be labeled person A versus person B. The program trains itself on this, and then when it's faced with the actual problem, each electronic neuron in the network spits out a conclusion. Yes, this is person A versus no, that's person B. And at the end, we have what is essentially organized chaos and a consensus reached by the neural network. If person A stands in front of the camera and the camera says it's person B, then the algorithm behind Face ID will go back for another round of training. After modifying the system slightly each time, making some changes to the training data after each testing period, we progressively get a program that can distinctly tell the difference between person A and person B. There are a lot of applications for this beyond in just mobile devices. For example, I've used a neural network run by a piece of software called TensorFlow, which is created by Google, to detect cases of diabetic retinopathy in images of retinas. Computers can now do what humans have been able to for millennia, learn and draw conclusions from looking at data. But there are issues surrounding this sort of technology, namely the ethical implications surrounding it. Neural networks are excellent at drawing conclusions and making assumptions, which is excellent for not only identifying photos and videos, but making them, or more precisely, faking them. We can now use neural networks, which are a part of free software packages, to fake videos. A neural network can take a digital mask of someone and overlay it over existing source footage, as you can see here in this video. The computer is watching his face movements and sending it to the computer, which is making assumptions about how George Bush's face would theoretically move and how the light falling on him would distort in comparison to how the actor moves his muscles and the actor's surrounding environment. The other problematic thing surrounding this technology is the training data. The training data is the data set given to an algorithm that allows it to learn, whether it's manipulating videos or identifying faces. Companies, who are the primary drivers of machine learning research, source their training data from the public. This means that when you're browsing on the web, companies are taking that data and using it to train their algorithms. A great example of this is web results. When you search on Google, they're taking your data and using it to train their algorithm to show you results that you agree with. The algorithm isn't consciously aware that it's participating in confirmation bias, but it is strengthening that bias in our minds regardless. Another issue with machine learning is that the algorithms produced are algorithms produced as a result of bad training data. An example of this would be Microsoft's social bot, Tay, that they launched on Twitter. A social bot is a computer program that communicates via social media, and this one in particular used machine learning to learn how to converse with other people over Twitter, and using the messages that it received as its training data. The issue with this is that people started to tweet anti-Semitic, racist, and sexist messages at the bot, and it began to say these same horrible messages because it wasn't consciously aware of what it was saying, just that it was popular and it got attention, which is what the bot was designed to do in the first place. The final issue with machine learning is that ultimately, machine learning algorithms are black boxes. We don't know how these programs learn the difference between person A and person B, just that it does, and that once it's trained, it's very good at doing this. And in a way, computers are becoming very much like the human brain. They're becoming smart enough to learn, they're becoming smart enough to make mistakes, and perhaps most terrifying, they're becoming smart enough to escape our own comprehension. Thank you.